We're going to step this up a notch, or we're going to step this up a dimension, and we're going to be looking at the intersection of planes in 3 space instead of just lines in 2 space. And so this is what it looks like in its simplest form. I have 3 planes and they're not parallel and they are intersecting in a single point. And so when I solve this system of equations algebraically, what I should come up with is the x, y, and z coordinate that satisfies all 3 planes simultaneously. And I'm going to do it by elimination. Now our strategy here is going to be to use one equation to eliminate x from the other 2 equations, and that will give us a system of 2 equations and 2 unknowns. That's all we're really going to be doing. And so here are my 3 equations that describe the planes. This is the scalar form, but notice that I've moved the constant over to the right hand side. You don't necessarily have to do that. It's more of a standard. First thing I'm going to do is I am going to eliminate x from equation 2, and I'm going to do that by multiplying equation 1 by 3 and equation 2 by 5 and subtracting the result. So 5 times equation 2 minus 3 times equation 1, there is 5 times equation 2. There is 3 times equation 1, and now I'm going to get my result, which is negative y plus 9z equals negative 10. This is my new equation 4. So there's the result of my first operation using equation 1 to eliminate x from equation 2. And so now I'm going to eliminate x from equation 3. Because the signs are opposite on the x, all I really have to do is take 5 times equation 3 and add 2 times equation 1. And so there's 5 times equation 2, there's 2 times equation 1, and now when I add the 2 together, I'm going to get the result. Negative 26y plus 9z equals negative 35, and that is going to become my equation 5. Now what I have is a new system of equations that are going to involve 2 equations and 2 unknowns. And from here, all you need to do is proceed with our elimination of 2 equations and 2 unknowns. Now all we have to do is solve for y or for z and substitute that into one of these 2 equations, and we'll be able to solve the system that way. So here's my new system of equations. When I do find my y and z, I'm going to substitute those values back into equation 1, and that will solve the system. Really a lot of busy work. This is called eCalc.com. And if you don't like doing those big elimination problems the way I don't like, you can actually use this calculator to do those problems. And so if we go to solve, and we are going to be solving a system of 3 by 3 equations, all I need to do is fill in my coefficients of the equation and the constant, and I can hit solve, and provided that system of equations is consistent, this calculator will solve a 3 by 3 for us. So there you go. I'll let you do that on the exam because solving 3 equations and 3 unknowns is a lot of busy work.